How to solve quadratic inequality? Well, that's a big question, and solving quadratic inequality is very different from solving linear inequalities. We'll soon see how. So we have two examples here, and with the help of these two examples, I hope we'll get to know the strategy which should be applied to solve quadratic inequalities. The first one is x squared less than 4. Now x squared is a parent quadratic function, and that's why it's a good equation to consider. And part B is the factored form of quadratic equation x minus a, where a and b are the two real roots. So it is x minus a times x minus b greater than 0. So I purposely taken two different kind of inequalities, one with less than and the other one with greater than sign. Now x squared less than 4, it really means what? If I sketch the graph of the function x squared, let us say we have coordinate x's, right? And if I sketch graph of x squared here, which will be like this, right? X squared, okay, that should have gone through the 0 itself. Then x squared less than 4 really means that if I draw a line y equals to 4, then everything, so this is y equals to 4 and this graph is x squared, this graph is x squared less than 4 means the part which is under the curve, under the line, right? So this part is what is our solution. As you can see, if you go beyond this point, the intersection of the graph x squared and y equals to 4, x squared is greater than 4, right? So it is up to the intersection, not including. So this point is not included, and that's what it means by saying less than, right? So it is not included, but everything in between is a part of solution, right? So let me just make it this. So there's a 0 in between. So that is the part of solution. Now, so the idea is to figure out where is x squared equal to 4, since these 2 points are the points where x squared is equal to 4. So therefore, in solving inequalities for quadratic equations, or you will see for any polynomial for that matter, we actually solve for equal to first and then figure out the interval where the inequality is satisfied. So now the question boils down to solving for x squared equals to 4. That is what it is. Now you know x squared is equal to 4 for x is equals to plus minus square root of 4, that is plus minus 2. So we get these 2 points as minus 2 and plus 2. As you can see from here, x squared less than 4 is satisfied when we are talking about an interval which is between minus 2 and plus 2, and therefore we can write that x is greater than minus 2 and less than plus 2. So that becomes the solution set, right? In the set form, we can always write this as x belongs to real numbers, where x is greater than minus 2 and less than 2. And that's how we get our solution. So that is one way of solving this. The other way is that we should bring all the terms to the left side. Now if I bring 4 to the left side, what do I get? I get x squared minus 4 less than 0. Right? That's a good way of solving. We bring all the terms to the left side and then factor the left side. Now here we can factor this as x plus 2 times x minus 2 less than 0, correct? So we got the factored form, and from here we know that x is equal to plus 2, in this case minus 2 here and plus 2 here, will give us a 0, right? So that means we get a 0 here when this equation, so these points we calculate, right? So these are the points that x equals to minus 2 and plus 2, right? So from the factors we know. Now the question is to figure out where is it less than 0. That means this product is negative, right? So that is the part which we are going to explore here on the right side. So we'll take a very general case and then figure it out, right? So we do have one solution for x squared less than 4. And now let's consider a general solution. And then we will see how really to solve a quadratic inequality. Now let's again consider the factored form of our quadratic equation. Here we are assuming that this coefficient is positive. That means we're just assuming this x square, x times x is positive, right? So that makes the job simpler for us. So in that case, we know if this is our, let us say, xy plane, then the graph of x minus a times x minus b should be kind of a parabola like this, right? So for the time being, we're just assuming these values to be positive. Well, a and b could be any value for that matter. We say, well, this point is a for us, and the x-intercepts are a and b basically, right? So if I write a here, I get a 0, that becomes an x-intercept, right? So at a and b, this quadratic function is 0. We're actually looking for a region which is greater than 0. So you will see in all these cases that when we are talking about greater than, then we are talking about an interval which is beyond these intercepts, not in between, towards infinity. Do you see that? So that becomes a part of solution. But if this would have been less than, as it was the case here, then we are talking about interval in between, right? So you get an idea. If I have an equation as x plus 2 times x minus 2 less than, I have solution in between the two. So that is the solution. Do you see that? But if I have greater than 0, then we are looking for region or the interval where this product is positive. You can see from here it is positive beyond b, right? So the answer here in this case is indeed it is between minus infinity to a, right? And from b to positive infinity. So that becomes our answer for this particular question in general, if it is greater than. Now if I take a case, let me say case C, where if I have x minus a times x minus b as less than 0, in that case the solution will be, let me draw this again here, right? So let's say we have something like this here, and a and b are general values, right? I'm just assuming them to be positive for the time being, right? Now here, if I say it's less than 0, then the solution is in between the two zeros. Then the solution is from a to b. Do you see that? That is the part of solution. If I have intervals so that x is less than, the product or the quadratic function is less than 0, then my answer is between the two. Do you see that? Now here again, let's go back to this. It is less than 0 and our solution is between plus 2 and minus 2. I hope you appreciate that part, right? Now, so that is in general how to solve quadratic inequalities. We will have number of examples now, and we'll solve quadratic inequalities graphically, algebraically, and with analyzing intervals. So 3 methods will be shared with you in the following videos. I hope you will get the whole concept. Thank you and all the best.